Okay, the last type of radical equation we're going to deal with today is one that's got radicals on both sides of the equation, and everything is inside the radicals on both sides. So this time we can't isolate the radical on one side of the equation because there are two radicals. So what I want is one of the radicals on one side and one of the radicals on the other side, which is in fact how this one is set up. So now I can raise both sides of the equation to an appropriate power. These are both square roots, so the appropriate power would be a second power. My pen is misbehaving. All right, so raising both sides to the second power. The effect on both sides of this equation is it's going to cancel the radicals on both sides. So that would give me 2x squared plus 3x minus 2 on the left. And on the right, I'd have 2x plus 13. Now, once again, I ended up with a quadratic equation. So to solve a quadratic equation, I want to get a 0 on one side, and then I'll try factoring. So I'm going to start by, I'm going to create the 0 on the right-hand side of this equation. So I'll do that by subtracting 2x from both sides and subtracting 13 from both sides. Okay, now the easiest way to solve this would be factoring if it is factorable. So I'm going to do a little scratch work on the side there. I do 2 times negative 15, which is negative 30. And I'm looking for things that'll multiply to make a negative 30 and add to make a positive 1. So after a quick run through the list, that means I would need to use 5 and 6. One of them has to be negative, so it would have to be the 5 that's negative. So when I add them, I get a positive 1. That means it will factor. So I'll go ahead and set up my 2 sets of parentheses. And when I'm starting this off, I need to focus just on that 2x squared first. Whatever I put in the first position in each of my factors has to multiply together to make 2x squared. So that would have to be 2x times x. Then my outside product, so 2x times something over here, has to equal one of my target numbers over here. Now, since it is 2 times something, I can't make the negative 5 without using a fraction, but I can make the 6 if I put in a 3 here. So this product gives me the positive 6. Now my other product, 1 times whatever I put over here, has to be the other number, the one I had not made yet. So that would have to be 1 times negative 5. Now that I've got it factored, I can set each of my factors equal to 0 to solve. And once again, you should be able to do this part in your head. So 2x minus 5 is 0 would give me x is 5 over 2. X plus 3 is 0 would give me x is negative 3. And now, of course, we do have to check our answers. So we have to check both of them, and we have to check them in the original equation. So that would be before I took the square root. Before I squared both sides. So I'm going to go ahead and set that up there. And we're going to check the answers one at a time. So we'll start with negative 3. So I'm putting a negative 3 in place of all my x's. On both sides of the equation. All right, now I need to calculate. So I need to do whatever is inside each of the radicals there. So I'm focusing on the inside of the one on the left here. The first thing I would need to do inside there is the power. So negative 3 squared is 9. And I think I'm going to go ahead and continue with the left side here so that I can continue focusing on the correct order of operations. So next I would need to do all of the multiplication that's in there. So 2 times 9 is 18. 3 times negative 3 is negative 9. And then minus 2. And finally, I can do all the addition and subtraction in order from left to right. So I've got 18 minus 9 minus 2, which would be 7. So now I've got the square root of 7 on the left. Now move to the right, and I'm going to continue simplifying the right-hand side. So I've got 2 times -3, which is -6. Then I've got -6 plus 13, which is 7. And so I ended up with the square root of 7 is equal to the square root of 7, which is true. The square root of 7 is not a real nice pretty number, so I wouldn't actually try to take the square root of it, but I can tell that those are equal to each other because they're identical. Okay, now we get to check the fun one, the the fraction. So we're going to be checking x equals 5/2. I think I'm going to not close my radical just yet. I'm going to see how much room this takes. So I'm putting in 5/2 for each of my x's. There we go. I made it fit. Okay. Same thing on the right-hand side of the equation. So that would be 2 times 5/2 plus 13. The screen moved. That was nice. Okay, so the right-hand side of this looks like it would be easier to do all of my addition and subtraction, everything, all of my operations. So I'm going to do the right side first. 2 times 5/2. The 2's just cancel, so that would give me 5. So that gives me 5 plus 13, which is 18. So I've got the square root of 18. Now, if this were as far as I was going, if this was going to be my x equals what my answer is, then I would need to simplify that radical. But what I'm really doing here is just trying to see if the left side and the right side are equal to each other. So I don't need to do that. I'm just going to leave it as square root of 18. Now I'll work on the left-hand side. So first thing I need to do is the square. 5/2 squared would be 25/4. Just going to copy the rest of it down there. Okay, next I would need to do all of my multiplication. So 2 times 25/4. I could cancel a 2 from the 2 and the 4. So that would give me 25/2. And 3 times 5/2, that's 3/1 times 5/2, so that would be 15/2. And then I see that I've got, well, no, let's just go with this, -2 there. Okay, so now I've got some addition and subtraction that I need to perform. I'm going to do the 25/2 plus 15/2 first. They have the same denominator, which is very convenient. So that gives me 40/2. And 40/2 is 20. So that would give me 20 minus 2. So I've got the square root of 20 minus 2 is equal to the square root of 18. And that's far enough for me to see that that is in fact a good answer. So this one actually has 2 answers, 5/2 and -3. All right, now you try the next one on the Google form.